Okay, so imagine this for a moment. You wake up tomorrow and every clock in the world stops making sense. Seconds stretch, hours shrink. Yesterday, today, and tomorrow start to blur together. It sounds impossible, but when physicists look closely at reality, they discover that time, the thing we trust the most, might actually be one of the biggest mysteries in the universe. Science has uncovered incredible laws that explain how stars are born, how galaxies move, and how atoms behave. But the deeper we dig into the fabric of reality, the stranger things become. Because some of the most fundamental pieces of the universe still don't make sense. These are some of the greatest unsolved mysteries in physics, questions that have puzzled scientists for decades, and in some cases, centuries. Number 10. The mystery of time itself. Time feels straightforward. It moves forward. Things age. You can't unburn toast or pour spilled coffee back into the cup. But physics tells a very different story. According to Einstein's theory of relativity, time isn't a universal clock ticking the same everywhere. It can stretch, bend, and slow down depending on speed and gravity. Astronauts aboard the International Space Station actually age a tiny bit slower than people on Earth. The difference is small, just milliseconds, but it proves that time flows differently depending on where you are and how fast you're moving. And that's only the beginning. In some of the equations used in quantum mechanics, the rules that describe the smallest particles in existence, time doesn't even appear. The mathematics still works without it. Which raises a strange possibility. What if time isn't fundamental at all? What if it's something that emerges from deeper physical processes we don't yet understand? There's another puzzle too. The laws of physics themselves don't prefer a direction for time. They work the same whether time moves forward or backward. But our experience clearly does. Broken glass doesn't reassemble. Smoke doesn't return to the candle. Physicists believe this one-way flow comes from entropy, the idea that disorder naturally increases over time. But even that explanation feels incomplete. Some theories suggest that past, present, and future might all exist simultaneously in what's called a block universe. In that picture, time isn't flowing at all. Everything already exists. We're just moving through it, one moment at a time. Number 9. The cosmic fine-tuning problem. At first glance, the universe looks chaotic, but when scientists measure its most basic properties, something astonishing appears. The constants of nature are incredibly precise. Values like the strength of gravity, the charge of the electron, or the energy of empty space are set to extremely specific numbers. If even one of them changed slightly, the universe would become completely different. Stars might never form. Atoms might fall apart. Life would almost certainly be impossible. Take gravity, for example. Compared to the electromagnetic force, gravity is about 10 to the minus 39th power weaker. If it were even a little stronger, the universe might have collapsed into black holes shortly after the Big Bang. If it were weaker, matter might never have gathered into galaxies. Another example is the cosmological constant, the energy contained in empty space. It appears to be tuned with astonishing accuracy, down to around 120 decimal places. That level of precision is almost unimaginable. So how did the universe end up balanced so perfectly? Some scientists believe it's pure chance. Others propose the multiverse, the idea that countless universes exist with different laws of physics, and we simply happen to live in the rare one where life can exist. Another possibility is more unsettling, that the universe somehow selects stable conditions through deeper laws we haven't discovered yet. Whatever the explanation, one fact remains. Reality seems balanced on an incredibly narrow edge. Number 8. The black hole information paradox. Black holes are already terrifying objects. Their gravity is so intense that once something crosses the event horizon, nothing, not even light, can escape. But the real puzzle appears when we think about information. In quantum mechanics, information about particles can never be destroyed. It might change form, but it must always exist somewhere. Yet, according to Einstein's general relativity, anything that falls into a black hole is gone forever. Both theories are extremely successful, but they can't both be right.
Then, in the 1970s, Stephen Hawking discovered something surprising. Black holes slowly emit energy, now known as Hawking radiation. Over enormous timescales, this radiation can cause a black hole to completely evaporate. If that happens, what happens to the information about everything that fell inside it? That contradiction is known as the black hole information paradox, and it's still unsolved. Some theories suggest the information escapes slowly within the radiation. Others propose it's stored on the event horizon itself, like a kind of holographic memory. There's even a possibility that our entire universe behaves like a hologram, where the information describing three-dimensional space is encoded on a distant cosmic boundary. If that idea is correct, black holes might not destroy information at all. They may simply rearrange it in ways we don't understand. Number 7. The matter-antimatter mystery. When the universe was born in the Big Bang, physics predicts that matter and antimatter should have formed in equal amounts. Antimatter is essentially a mirror version of matter. When they meet, they annihilate each other instantly. If perfect symmetry existed, everything would have disappeared in a flash of energy. But clearly that didn't happen. The universe today is made almost entirely of matter. Antimatter is extremely rare. Somewhere in the earliest moments of cosmic history, a tiny imbalance occurred. For every billion matter-antimatter pairs that formed, roughly one extra matter particle survived. That tiny leftover became everything. Every galaxy, every planet, every ocean, every living organism, all of it comes from that microscopic difference. Physicists call this baryon asymmetry, and its cause remains unknown. Some theories point to neutrinos behaving differently in the early universe. Others involve subtle violations of symmetry in particle physics. But so far, no explanation is complete. The entire universe exists because reality tilted ever so slightly in one direction.
Number 6. Quantum entanglement, the universe's strangest connection. Einstein once called it spooky action at a distance. Quantum entanglement occurs when two particles become linked so that the state of one instantly affects the other, no matter how far apart they are. You could separate them by light years, and measuring one would still influence the other. This shouldn't be possible. Nothing, not matter, energy, or information, is supposed to travel faster than light. But entanglement doesn't seem to involve any signal traveling between the particles at all. Instead, the pair behaves as a single system. Experiments have confirmed this effect again and again, and some physicists suspect it might be more than just a quantum curiosity. There are theories suggesting that spacetime itself could emerge from vast networks of entangled particles. If that's true, the very structure of reality may be built from invisible quantum connections. Number 5. The Multiverse Hypothesis. Imagine that our entire universe is only one bubble among many. The multiverse idea proposes that the Big Bang might not have been a unique event. Instead, universes could be forming constantly in an enormous cosmic landscape. Each universe might have different laws of physics, different constants, different dimensions. Some might collapse instantly, others could look nothing like ours. Inflation theory, the rapid expansion thought to occur just after the Big Bang, actually allows for this possibility. If space can inflate once, it might do so again in other regions. Each region could become its own universe. So far, there's no direct evidence, but the mathematics doesn't rule it out. If the multiverse exists, our universe might simply be one of countless cosmic experiments. Number 4. Vacuum decay, the silent apocalypse. Now imagine the quietest end of the universe possible. No explosion, no warning, just instant disappearance. Physicists call this scenario vacuum decay. Our universe might exist in what's known as a false vacuum, a state that looks stable but isn't the lowest possible energy state. Picture a ball resting in a shallow valley while a deeper valley lies nearby. A random quantum fluctuation could push the ball over the edge. If that happened, a bubble of true vacuum would form and expand outward at the speed of light. Inside that bubble, the laws of physics could completely change. Atoms might not exist, matter itself might become impossible. And because the bubble moves at light speed, nothing could ever see it coming. One moment the universe exists, the next moment it doesn't. Number 3. The origin of mass. Mass feels like something obvious. Objects weigh something. Simple. But for decades, physicists didn't know why particles had mass at all. The breakthrough came in 2012 with the discovery of the Higgs boson. This particle confirmed the existence of the Higgs field, an invisible field filling the universe. When particles interact with it, they gain mass. The stronger the interaction, the heavier the particle. But the story isn't that simple. The Higgs field doesn't explain why particles have the exact masses they do. And even stranger, most of the mass in your body doesn't come from the Higgs field at all. Nearly 99% of it comes from energy created by the strong nuclear force binding quarks together inside protons and neutrons. In other words, most of your mass is actually energy trapped by fundamental forces. Number 2. Quantum consciousness. One of the strangest unsolved mysteries in science isn't about space, it's about the mind. What exactly is consciousness? Most neuroscientists believe it's a byproduct of brain activity, neurons firing in complex patterns. But some researchers have proposed something radical. Physicist Roger Penrose and others have suggested that quantum processes inside neurons might play a role in conscious thought. According to this idea, the brain might operate partly like a quantum computer. If that were true, it could help explain creativity, intuition, and perhaps even the strange relationship between observation and reality in quantum experiments. The idea is controversial, but there's a deeper problem scientists still can't solve. Why does brain activity produce experience at all? Why do electrical signals create sensations like pain, joy, or fear? Why is there a conscious you behind your eyes? The physics of consciousness remains one of the biggest gaps in our understanding of reality. Number 1. The possible limits of physics. Physics has achieved extraordinary things. We've unified electricity and magnetism, discovered relativity, and built quantum mechanics, one of the most successful scientific theories ever created. But some scientists worry we might be approaching a fundamental limit. The smallest meaningful scale in physics, the Planck scale, is so tiny that even our most powerful machines may never be able to probe it. Particle accelerators might never reach those energies. Experiments might never test what happens there. If that's true, some parts of reality could remain permanently beyond observation. Mathematics might suggest the answers, but experiments might never confirm them. And that's the nightmare scenario for science. What if reality contains truths that no civilization can ever uncover? Others remain optimistic. After all, physics has reinvented itself many times before. Newton's laws led to Einstein's relativity. Relativity eventually met quantum mechanics. Maybe another revolution still lies ahead. But one thing is clear. The deeper we explore the universe, the more mysterious it becomes. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.